Today I will discuss you about topic called baselining. So it is nothing but a step-by-step procedure for doing a STA analysis. So before going to doing a timing analysis for any design, you need to follow some certain steps. So that is called nothing but a baselining. So the definition of the baselining is it is a process in which it is a step-by-step procedure to approach STA analysis. So these are the steps. So first step is to apply constraint for edge to edge path. So we know that edge to edge path is the pure combinational path. So we need to apply suitable constraints. So constraints is nothing but it should be a clock. For a edge to edge, the constraint is like clock. So you need to analyze the maximum data path in the edge to edge path, and you have to apply greater than that means above data path you have to give the clock period. Okay, if it is your data path period is 6 nanoseconds, you have to apply 7. Thereby you will get the clock, you will get the slack is positive. So first step is apply suitable constant to the edge to edge path. Then once it is constrained, we can go to input to edge path. So apply constraints to input to edge path. So we know that if we give the set input delay constraint, it is taken for the input to edge path timing analysis. So that is the third step. So we will go in depth afterwards. So I am explaining on the steps, you follow the steps while doing the ST. The next thing, once it about 2 are constrained, then you can go for constraining edge to output path. Okay, so once it is constrained, so you can constrain the edge to output path. It is nothing but set output delay. So always set output delay should be minimum, so that you will get a better slack. So once all these 3 done, you can check the false path if it is not met timing, or otherwise if it is not met timing, you can go for the timing exceptions. So once these 3 are done, it is not necessary to do check false path and timing, especially timing exceptions. You can apply synthesis techniques and to get the meeting timing. If still it is not met timing, go for the timing exceptions. So timing exceptions, there is a priority to check or to give the constraint. So the priority comes with check false path. It is better to have check your timing constraints. So check the timing constraints. Is there any possibilities in your design and your constraint time? So the constraints will be, the priority will be clock groups, which comes as a asynchronous. So first you give the priority where there is an asynchronous path or there or not, and you give the constraint. So next is false path. So see, is there any false path in your design, and apply set false path from this source to destination. So next is set min and max delay. So this is comes under third priority, set max and min delay, which is called constant for the pure combination. Then you can check there is a pure combination in your design so that your time is not met. So apply proper constants in your design, then you check your time is met or not. Still your time is not met, check is there any multi-cycle path. Okay, so we know that multi-cycle path is more than one cycle it will takes between the edge to edge path or edge to out or input to edge. Okay, so once it is take multi-cycle path, you can give constant, then it may met the time. So once if you check all those things, all the 4 steps you check under constraint in your design, still your design is not met, go for implementation techniques such as floor planning. Floor planning and physical optimization. So check with first of all with physical optimization, then you work if it is time is not met, and you can apply floor planning when your resources are greater than 80. Resource utilization, so you can check any resource utilization, if it is flip-flop or all latches or BRAM or DRAM, whatever. If it is resources are utilized greater than 80%, then you can able to go for floor planning. Create play block of the design and you can place it in another place so that the routing will take place less time, so net delay will be decreased and you will get the proper slack so that there will be no violation. So once I will explain from this from the starting. So it is a step-to-step procedure, steps to follow. First is raise to output path, raise to reach path, so raise to reach path, then input to reach path, then raise to output path. Then need to apply timing constants. If 4 steps if the 3 designs are not met the timing, you can check the timing constants. If it is a pure combination, you know that there is no raise to reach path, input to reach path, you can directly goes to set min max delay. Okay, so if it is a pure combination, directly comes to this path. So if it is not there, you can come to this. So before that you have to check where there is a false path or not, because it has a higher priority. So once it's done, so set min delay comes with the timing constants. So you have to check one by one priority. So this is a priority. Okay. Highest priority always the asynchronous clock loops. Okay. Once it does not meet if all those 4 conditions, so you can better to go for physical optimization. Okay. Physical optimization, you do the optimization of your place and optimization of your route during the implementation time. So once it's done, it may reduce retiming or net delay, reducing the net delay. It can do it, it depends upon the tool. So once it's done, still it is not met timing, you can go for flow planning, but the condition is to have resources utilization greater than 80%. So you can see the resource utilization of your design. If it is greater than 80, you can go for floor planning. So still it is not met timing, so after the fifth condition also, so you need to change. Still not met timing, need to increase increase frequency. So before coming to um, implementation, so you have to use physical, that means synthesis techniques, which is called pipelining, resource sharing, retiming and all. So you have to apply and check it if possibility to meet the time. Then it still does not meet time, you can come to increase frequency. So this is not recommended. Okay, or change the board as per your requirement. Okay, so thank you.